Hello everyone, this is a very awesome identification image transfer, or you can call it the face swap technique called PuLID. Right here, we have the new Flux PuLID, which enables you to create not only one character, but even multiple characters within an image for the identification of a character to be applied to an image. Now, we're not calling this a face swap because face swaps, like in ReActor face swap nodes, only place the face of one image onto another, but here, as you can see, the output of the face, what we call the identification of a character, is going to be transformed from a source image. For example, we've got these two source images, and they become something like this. Of course, the text prompts are going to change the whole theme. The themes and styles become purple, and you'll see the light effects of the image blend in seamlessly with the character itself. It also won't look awkward, unlike when we previously used ReActor face swap. After changing the face in an image, you'd sometimes see some awkward lighting that needed fine-tuning adjustments. So how do we do that? Let's check it out. In this video, we have a lot of things to talk about, and you'll see my ComfyUI tools bar here. I've got lots of workflows. So, why is that? First of all, we have the ComfyUI PuLID Flux 2. These custom nodes are the new rewritten versions of the previous ComfyUI PuLID Flux. I haven't mentioned this before in my other videos because it didn't look good. It was horrible. As you can see in this Albert Einstein PuLID identification image, there are all these rusty dot-like pixels. It's like if your blade is turning rusty, but it's stuck on the face. The eyeball isn't even clear, and the hair looks pixelated. This is what the author of PuLID Flux calls model pollution. In simple terms, it's not rendering the latent noise in a better way to transform the face. As a result, Einstein's face looks very pixelated, and the hair isn't clear. It's all messy without any clean line traces for each strand. It just looks horrible. But after fine-tuning and modifications, the new version, Flux PuLID version 2, has seen a lot of improvements. Additionally, these custom nodes include other custom nodes from the same author that use Teacache and the first block cache technique, which we're familiar with from WaveSpeed in ComfyUI. We've talked about this in other videos, how ComfyUI WaveSpeed improves model loading pre-configuration time by caching blocks of data, allowing it to run faster, and of course we use TCache. This improves the speed during the AI's image or video rendering in the sampling steps, sometimes cutting the processing time in half, or even to 1/3 of the normal rendering method. The author has also created a node called ComfyUI Patch 2, which integrates with ComfyUI PuLID Flux 2. As mentioned in the description here, it states that to use Teacache, you need to use the ComfyUI Patch tool. It won't use the ComfyUI cache in other custom nodes. I believe some people have talked about this. ComfyUI Teacache custom nodes are dedicated to running Teacache for certain AI models. But with ComfyUI Patch 2, it's able to run on most of the latest AI models that support it in ComfyUI, such as Flux, LTX videos, and Mochi 1 Preview AI video models. The support for both caching and the Speedway technique, like WaveSpeed, is also included in one package. It's very convenient. I've installed it, and you don't need any additional Python or PIP installs, or to go through the requirements.txt or anything like that. I'll show you how it works. Simply install it, and the first thing you need to do is, if you have the old ComfyUI PuLID Flux, the previous version with ugly pixelated render styles, you'll need to delete it and install this new one called PuLID Flux 2. Then you're good to go. Also, those old versions of custom nodes, like Apply PuLID Flux, need to be removed. We're going to use this new package of custom nodes. As you can see here, there are some examples, including the mass attention examples I showed at the beginning of this video. These involve two characters using their facial and body shape identities to create a new image based on the mask that allocates those two characters onto the new image. Of course, you'll see there's a mask combine and an invert mask for the second character, etc. We can talk about that later and go more in depth on mass attention. The easiest and most basic one, of course, is handling one character's face and identity to create a new image. I wouldn't say this is a face swap technique, but it can perform similar features to ReActor face swap because they share similarities in function and usage. However, as you can see in my examples here, the characters look more natural in terms of their faces. You won't see any borders between the face and the image, unlike with ReActor face swap, where sometimes the face isn't fully integrated and you might see pixelation around the edges, but this one isn't going to happen like that. So I think this is going to be a better performing option and is easier to install compared to ReActor face swap. A lot of people have had trouble installing ReActor face swap previously, and right now ReActor face swaps are disabled by GitHub due to some restrictions and other issues. We won't be able to use that again, at least not in the near future. It's unclear when or if they can recover from this situation. So we'll be using something else that's safer and not tied to GitHub. It's not going to be harmful to people's computer systems, so let's check it out. First, we'll go over how to install this, and then we'll move on to setting up each of the nodes. Even though you see a lot of connections here, there's a very easy way to identify how to use it with just a simple concept. You can apply it to almost every face swap situation, or what we call character identity creation for a new image. First, of course, you'll need to go back to the GitHub repository for these custom nodes called ComfyUI PuLID Flux 2. You install this one without needing to use GitHub or clone commands in the command prompt window. The easiest way, of course, is to use the ComfyUI manager. For example, I've already installed it, but I'll walk you through the steps here. If you're starting with an empty workflow diagram, begin by going to the manager. Once the manager appears, go to Custom Nodes and start searching for PuLID Flux 2. It will appear in the results, and you'll see the install button if you haven't installed it yet. You'll notice it's from the author LL Dacing. This is the person who created these custom nodes. I'm using version 0, 9.1 model of ComfyUI PuLID Flux. One more thing about versioning. You'll need to install the latest ComfyUI update. Remember to update your ComfyUI. I'm using ComfyUI 0, 3.10, which is compatible with the latest versions of these custom nodes. So before you install these new custom nodes, make sure your ComfyUI is up to date. Once that's done, go back to the ComfyUI manager, search for PuLID Flux 2, and install it. This is the basic custom node for PuLID Flux 2. If you want to use the advanced features mentioned in their GitHub repository page, like Teacache and the ComfyUI WaveSpeed technique to generate faster image generations using their caching techniques and the first block cache technique, you'll also need to install ComfyUI Patch 2, which is from the same author. As you can see, the author's name is at the top here. This custom node supports Flux Genuine videos, LTX videos, and Mochi videos. You'll also notice a note here. You need to upgrade to ComfyUI version 0, 3.7 or above. I'm already using a version above this requirement, so I'm able to run it without issues. Now, let's check out how to implement this and run it for face identifications, or what we call the face swap technique, in an easier and simpler way. The first thing you'll need to download is the PuLID Flux custom models. I've provided all the links in the setup guide. I might create a blog post on my website and link it in the video description below so you guys can check it out. I'll aggregate all the content links and steps there. As you can see here, there's PuLID Flux version 0, 9.0 and a newer version, 0, 9.1. Either one will work with the ComfyUI custom nodes we're installing right now, but I prefer the newer version. It's about 1.1 gigabytes in size. Next, we're going to place this file in the ComfyUI models folder. I've marked down all the steps here. You'll need to manually create a subfolder called PuLID inside the ComfyUI models folder and then place the saved tensor model file there. In practice, it'll look like this. You'll have your ComfyUI folder, go into the models folder, and create a PuLID subfolder. I've already done this before recording this video, and I've placed my model files here. That's step 1. Step 2 involves using the clip files, which you can download automatically. However, I recommend downloading them beforehand because sometimes relying on the custom nodes to download them automatically can crash ComfyUI or cause it to freeze, forcing you to restart it repeatedly. So go to the models folder, then the clip folder, and download the file from the link provided here. Let's say I've already navigated to the Hugging Face page. Download this clip file, it's about 800 megabytes, and just press the download button to get it. It's very self-explanatory. And of course, we're going to put that in the correct locations, specifically the models and clip folders. However, I suggest not restarting ComfyUI yet until we've installed everything. The third step involves installing the face library dependency, which will be automatically downloaded the first time you run the PuLID custom nodes in ComfyUI. This will be installed in your system files by itself, so you don't need to handle this manually. The last step is downloading the face detection model files. Again, I recommend downloading these manually to avoid issues. Be careful with this step. Inside the models folder, create a subfolder called InsightFace, and inside that, create another subfolder called Models. Place the downloaded files here. You'll find the download link provided, which will take you to a page with several model files. There's also a zip file package that includes all the necessary model files. Download this zip file and place it in the InsightFace Models folder. Once you've done that, unzip the file and it will create the necessary folder structure with all the face detection model files inside. After completing these 4 steps, you'll have everything set up for ComfyUI PuLID Flux 2. Additionally, use the ComfyUI Manager to search for and install ComfyUI Patch 2, which I've already installed as well. These 2 custom nodes don't require any pip installs or editing of requirements.txt files, at least in my setup they didn't, so I don't think this will be a problem for most people. Just be mindful and focused when downloading the 3 model files from the provided links. Pay special attention to the zip file and ensure it's extracted into the correct folder path. Don't rush through this process. I know some people tend to zone out during tutorials and end up clicking randomly, placing files in the wrong folders. That won't work, and it'll just waste your time. So stay sharp. Now, let's talk about how to run this workflow. All the necessary files are included in the ComfyUI Custom Nodes folder. If you go to the Examples folder, you'll see workflows like PuLID with Attention Mask and PuLID with Speed Up. The Attention Mask workflow is for handling multiple characters, while the Speed Up workflow demonstrates how to load an image and apply the PuLID Flux technique. For example, in the Speed Up workflow, you'll load an image and pass it to the Apply PuLID Flux node. This node enables the model data loading and diffusion model. As you can see here, I'm using the Flux model. The data flows from the model, utilizing the PuLID models we downloaded earlier, the PuLID models, clip models, and the InsightFace models for face detection. Here, you'll also see a Load Image node where you can input any image, whether it's an AI-generated character, a family photo, or even your girlfriend's picture. Attach that image to the input connection, and once processed, the output will be the transform model data. You can see this clearly represented by the purple dot in the workflow. The demo workflow also shows the use of Teacache from the Patch 2 custom nodes, written by the same author as PuLID Flux 2. We're using the Teacache technique here, and there's a side-by-side comparison included in the workflow. The author has combined all these custom nodes into a somewhat spaghetti-like arrangement of lines, but the core idea is clear. One part of the workflow demonstrates the Apply First Block Cache from WaveSpeed, another custom node used for caching and speeding up generation. The author wanted to show how much faster the process is when using TCache, so they've included duplicate sampling schedulers for comparison. You can see the custom sampling nodes renamed for clarity, one for WaveSpeed, one for TCache, and one for the base generation without any caching techniques. At the end, you'll see 3 images generated. The first is the base generation without caching, the second uses, and the third uses WaveSpeed. The author accidentally mislabeled the third image, but it's meant to represent WaveSpeed. Let me correct that for clarity. There we go, now the titles are accurate. So why did the author include this side-by-side comparison? Because the timing differences are significant. Now, I'll show you another example using a different input image so you can see how it all comes together. So here, I've got another AI character image that I generated earlier. It's a general close-up portrait of a character. This time, it won't feature the same outfit, like the green jacket or cyber-futuristic style. Instead, it's influenced by the text prompts, resulting in a light pink, purple tank top, as you can see here. The light pink tank top with straps and the natural makeup-free look are all coming from the prompts. This works well for the demo because it makes the differences in the face and performance very clear. Let's bring up the command prompt window on the side so you can see how the processing differs. I'll move it closer, and we'll observe the sampling steps for each of the 3 samplers. The speed differences are quite noticeable. Let's run the first sampler, which doesn't use Teacache or WaveSpeed. You'll see the green loading bar moving slowly but steadily. Next, the Teacache sampler finishes almost instantly. Lastly, the WaveSpeed sampler shows a slight improvement in speed, but it doesn't properly render the facial identification for the character. This woman's face isn't accurately generated. The WaveSpeed technique, using the Apply First Block Cache custom node, isn't compatible with PuLID Flux for facial recognition and generating new images. As a result, it transforms the face into a different woman's appearance. I think this is what the author wanted to demonstrate. Other caching techniques like WaveSpeed aren't compatible with PuLID Flux for facial recognition and image generation. The first two samplers, base generation and Teacache, aren't affected by this issue because the same author wrote the code for both Teacache and PuLID Flux, ensuring compatibility. Now, let's compare the results. The base generation, without caching, and the Teacache generation are very similar, but there are slight differences. The base image has more solid coloration, while the Teacache image has lighter tones. For example, the lips, eyebrows, and hair are a darker brown in the base image, whereas the Teacache image shows a lighter shade of brown. Let's try another image for comparison. I'll use my good old AI character Nancy. We'll generate her image to better compare the two techniques, one without Teacache and one with Teacache. As for the third sampler, using WaveSpeed, we don't need to test it again since it's not suitable for our needs. Without caching, the colors are more solid and vibrant. This is the trade-off. Teacache speeds up the process but may result in lighter tones, while the base generation takes longer but produces more solid colors. It's up to you to decide which works best for your needs. This comparison shows that the first block cache technique performs slightly better than Teacache in terms of image quality, while the generation times are similar. Without caching, it takes about 15 seconds to generate an image. But with first block cache or Teacache, it only takes around 6 seconds. I'd say the first block cache is the better option because the coloration is much closer to the non-cached image, whereas Teacache tends to produce lighter tones. For example, in the previous demo, the Teacache image had noticeable color offsets, like the dark brown hair appearing lighter and the tank top and lips looking slightly different. With the first block cache, the colors remain more consistent, which is why I prefer it for generating images with PuLID Flux. Additionally, the first block cache custom nodes using the DIT forward overrider can also be used independently of PuLID Flux. For instance, if I want to modify this workflow without applying PuLID for face swapping, I can bypass the PuLID nodes and just run the sampler with the first block cache. This saves time and allows us to focus solely on the diffusion model without PuLID. Let's try that now. I'll bypass the PuLID nodes and only use the first block cache to generate an image. Since we're not using PuLID, the face won't match the input character, so we'll get a different result. Here we go. The image features an Asian female and the generation time is about 7 seconds. Let's run it again to see the real-time generation, and it's consistently around 7 seconds. This demonstrates how the first block cache from the ComfyUI Patch 2 custom nodes works efficiently without requiring additional installations like Triton. It's straightforward. Just install it through the ComfyUI Manager and it works seamlessly. If you want to re-enable PuLID for face swapping or applying your own character's identity, you can easily reconnect the PuLID nodes. For example, I can remove the top scheduler and focus on the first block cache connections between the diffusion model and PuLID Flux. This setup works well for applying the character's face while leveraging the first block cache for faster generation. Now, let's talk about the attention mask feature, which is a fascinating aspect of PuLID Flux. In this workflow, we're using an attention mask for 2 PuLID Flux characters. Why? Because we have 2 reference characters, and we need to allocate them properly in the image. To do this, we use 2 masks created from solid colors, one for each character. These masks are combined into a single black and white image, and the invert mask node switches the colors to allocate the characters side by side. For example, I've loaded one character here and my AI character Nancy in the other slot. This allows us to generate an image featuring both characters. If you want to adjust the theme, say reduce the purple and neon light effects, you can modify the text prompts. For instance, let's set the scene as a normal Tokyo street with two women captured in a close-up shot. Instead of hoodies, let's dress them in elegant dining dresses to enhance their beauty. And for their hair, let's go with striking purple instead of a more natural color. Just use normal hair as referenced from their identity. I think that's better. Also, we don't need those neon light effects. Instead, I want something cleaner. So, I've cleaned up the text prompts. I'm not a fan of the overly cyberpunk feel. Let's keep it simple and capture two women having a photograph on the streets of Tokyo. Let's see how that turns out. By default, the workflow example from the author uses Teacache. This is our first generation attempt. And there you go, we've got an image combining two characters, featuring two good-looking ladies in one frame. It follows the prompts pretty well, though you could enhance the positioning and dress details further. Now, let's say we want to apply the first block cache instead of Teacache. Some people, including myself, prefer the first block cache for certain scenarios. To do this, we'll first remove the Teacache nodes and replace them with the first block cache technique. I'll create a group here for better organization and adjust the model connections accordingly. We'll connect the basic guider and scheduler for the model, and let's see how it looks. I'll isolate the TCache section and create another image preview for the first block cache result. Here's the side-by-side comparison. The first image is generated using the first block cache, and the second is from TCache, which we generated earlier. Looking at both examples, I personally prefer the first block cache for close-up portraits. It brings out more solid and vibrant colors. For instance, compare the hair and skin tones. The TCache image has slightly lighter, less saturated colors, which can make the image feel less sharp. For advertising creatives, where eye-catching sharp colors are essential, I'd lean toward the first block cache. However, if you're going for a softer, more artistic look, TCache might be more suitable. Let's generate one more image using the first block cache to confirm. The generation time is about the same, around 8 seconds for both caching techniques. Even with an NVIDIA 4090, there's no significant difference in timing between the two. However, without any caching, the generation time would be nearly double. So that's the conclusion. The first block cache offers more vibrant colors, while TCache provides a softer look. Both are efficient in terms of speed, but the choice depends on your specific needs. That's it for this quick tutorial on using PuLID Flux and the new caching techniques to generate images faster. In the next video, I might explore combining PuLID Flux with other techniques to create more practical workflows rather than just merging two images into one. Thanks for watching, and I'll see you in the next one. Have a nice day. See ya!